Hey guys, we're looking at page 3 of the Unit 2 Linear Functions Test Review. So let's graph the function and identify the key characteristics. Before we can even graph a function, we need to make sure that it is in slope-intercept form. So right now we've been given the function 4x minus 4y is equal to negative 8. We need to go ahead and get y by itself by subtracting 4x from both sides. This will give us negative 4y is equal to negative 4x minus 8. And then we need to divide each term by negative 4. So our slope-intercept form of this function is y equals x plus 2. That's going to give us a y-intercept at 0, 2. And we're going to have a slope of 1. So we're going to go up 1 to the right 1. Or we could go, sorry about that, guys. We can go down 1 to the left 1. And we can connect the dots. For this function, our domain, and guys, we could have put some values here if you wanted to. Like if we give you values on the test, go ahead and evaluate them. So let's say I put where x is 0, negative 1, negative 2, 1, and 2. I can look at the outputs for those values. So when x is 0, y is 2. When x is negative 1, y is 1. When x is negative 2, y is 0. And I can go the other way. When x is 1, y is 3, 4, and 5 because we have a slope of 1. Now our domain, it's all real values. We're not stopping left to right. So I'm going to write this in set builder notation. You got your bracket, which for some reason when I try to write my brackets on my iPad, they don't turn out right. So I've got x bar x for all elements of real numbers. Range is likewise, except instead of x values, we're looking at y bar y for all elements of real numbers. And we do have an x-intercept here. Our x-intercept is at negative 2, 0. Our y-intercept was at 0, 2. This function is always increasing, so it's going to be from the interval of negative infinity to positive infinity. There will be no decrease. When x goes to positive infinity, y is going to positive infinity. And when x goes to negative infinity, y goes to negative infinity. And that is the full characteristics for that function. We're going to do the same thing for number 13. First off, we've got to get y by itself. So I'm going to be left with 3y equals negative 2x minus 6. And then I'm going to divide by 3. So y equals negative 2/3 x minus 2. So I know I have a y-intercept at 0, negative 2. And I'm going to go by 3s to make our lives a little bit easier. So I'm going to say, let's look at where x is negative 3, where x is negative 9, or negative 6, excuse me there. And then we can go 3, 6, 9 on the right-hand side. Guys, you could plug this into your calculator. So you could use the table function, and you could say f of x is equal to negative 2/3 x minus 6, or excuse me, minus 2. So we're going from that slope-intercept form. So at negative 6, we get the output of 2. At negative 3, we get the output of 0. At 3, we get the output of negative 4. 6, we get the output of negative 6. And 9, we get negative 8. So let's graph that. So I've got 0, negative 2 with a slope of down 2 to the right 3. So down 2 to the right 3. Or I can go up 2 to the left 3. And if we look, our values do align. The ones that are in the table do align with what's on our graph. Our domain is all real numbers again. So I'm going to go ahead and put this in set builder notation. So I've got x bar x for all elements of real numbers. My range, I've got y bar y for all elements of real numbers. I accidentally put that on my x-intercept. My x-intercept, in this case, I apologize for that, guys, is -3, 0. So that's where y equals 0. Our y-intercept was 0, -2. We get that as the b term from our slope-intercept form. This function has a negative slope, so it's never going to increase. So I'm going to put none for the increase. And it's constantly decreasing over the interval of -infinity to +infinity. So when x goes to +infinity, y is going to -infinity. When x goes to -infinity, y is going to +infinity. And guys, that leads us into sequences.